Hello and welcome to the channel, the Cambridge Advanced Level Mathematics channel. In today's video, we want to look at a simple and easy and fascinating way of expanding 1 plus x to the power 7 or to the power 8 or to the power 9. Now, how do we do that? First of all, suppose we have our binomial expression 1 plus x raised to the power n. Now, let's start with n is equal to 0. So we have 1 plus x to the power 0. We all know this should give us 1 because any number raised to the power 0 is 1. 1 million to the power 0 is 1. 1 billion raised to the power 0 is 1. Okay? Next, let's put n is equal to 1. So we have brackets 1 plus x to the power 1 is just the 1 plus x itself. What about n is equal to 2? We have 1 plus x to the power 2 is equal to 1 plus 2x plus x squared. It's the good old quadratic expression there, but my 2 doesn't look pretty. Let me try and sort it out. Okay, so there you are. That's x squared. All right, n is equal to 3 gives us 1 plus x to the power 3 is equal to 1 plus 3x plus 3x squared here plus x cubed. N is equal to 4 gives us 1 plus x to the power 4 is equal to 1 plus 4x plus 6x squared plus 4x cubed plus x to the power 4. Okay? Finally, let's try n is equal to 5. So that gives us 1 plus x to the power 5 is equal to 1 plus 5x plus 10x plus 10x squared here, 10x cubed here, plus 5x to the power 4 plus x to the power 5. First of all, let's notice a few things. Let's observe a few things here. It starts with this one raised to all the coefficient of the first term is just 1. And the coefficient of our last term, which is x raised to the last power, to the power n there, is actually also 1. By the coefficient, I mean the number that multiplies the x there. Here, the coefficient of x to the power 4 is 5. Here, the coefficient of x is 3. Okay, so let's come over here to the other board and collect all the coefficients of the x terms. We are not going to be worried about the x's themselves. Let's just collect them together and put them in a nice pyramid-like shape. Okay, this is what I mean. So, for the first one there, with n is equal to 0, we just put a 1. The next one, for x, n is equal to 1, it is 1 and a 1. Remember, we are just booking the coefficients. We are not interested in anything else. Then we go to x squared. 1 plus x squared, where n is equal to 2. It gave us 1 and 2 and a 1. The next one was 1 plus x cubed. It gave us a 1 and a 3 and a 3 and a 1. So we have a 1 and a 3, and a 3, and a 1. The next one gave us was the n to the power n was 4. It gave us 1 and a 4 and a 6 and a 4 and a 1. So it gives us here a 1 and a 4 and a 6 and a 4 here, and of course a 1. Lastly, n was 5. We got a 1 and a 5 and a 10 and a 10 and a 5 and a 1. So we put a 1 here, we get a 5 here, we get a 10 here, we get a 10 here, and we get a 5 here, and we get a 1 here. The first thing that we notice in our pyramid, or triangle if you like, is that the sides apart from the base, they all consist of ones. There's 1 here and 1 there, just like we had it here. All these are ones, and of course the coefficients of the last term, the highest power of x, is equal to 1. That's what is being reflected here. The next thing that we want to observe, we want to see if we can pick up a pattern. Let's just choose one coefficient. I will choose these 2 here. And I'll start to look around the 2. When I look at the coefficient directly above it, is it directly above it? No, just above it, but to the left and to the right. I have got a 1 here, and I've got a 1 there. And a 1 plus a 1 gives me a 2. Okay, let's see if that continues throughout the triangle. So here, I will put it in a nice box there. Was it a box? I don't know. So a 1 and a 1 give me a 2. Let's choose another coefficient at random. I will choose this 5 here. Above the 5, to the left and to the right, I have got a 4 and a 1. And incidentally, 1 plus 4 gives us a 5. So here we are. The same pattern persists. Okay. Another one, let's choose this 4. You look up to the right, there is a 1. To this other side, there is also a 1. Incidentally, 3 plus 1 gives us a 4. So there is the pattern again. Okay. And you can choose any one coefficient that you like. I'm not going to try and mess up the picture by choosing more of these, but we can still point at any coefficient and pick up the same pattern. For example, our 10 here is given by a 6 and a 4. This 10 also here is a 6 and a 4. This 5 here is a 4 and a 1. This 3 here is a 2 and a 1. This 3 here is a 2 and a 1 again. So it looks like once you have got the terms above, you can actually determine what is below. So remember, we ended up at n is equal to 5. Let us try and construct further down using now our n is equal to 6. So our 6 now will give us, of course, we always have a 1 there. Then we have a 1 plus a 5, we will have a 6 here. Then a 5 plus a 10, it gives us a 15 here. Then a 10 and a 10 gives us a 20 here. A 10 and a 5 gives us a 15 here. A 5 and a 1 gives us a 6. And of course, we should have a 1 there at the end. Our target was 1 plus x to the power 7. Here we go. We will have a 1 here. And then 1 plus 6 gives us a 7. A 6 and a 15 gives us a 21. A 15 and a 20 gives us a 35. A 20 and a 15 gives us a 35 again. A 15 and a 6 gives us a 21. And a 6 and a 1 gives us a 7. And of course, we must have our 1 there. We can continue. If we were interested in 1 plus x to the power 8, we would have a 1 here, an 8 here, a 28 here, 56 here, a 70 here, a 56 here, a 28 here, an 8 here, and a 1 here outside the board. This is what is called Pascal's triangle. It can be used to determine the coefficients of any expansion of 1 plus x or any binomial expression. Remember, a binomial expression is an expression, is really a difference or sum of two terms. Here it is 1 plus x. It could have been 2 plus 3x squared. It could have been a plus x. It's still a binomial. And given that binomial, you can find the coefficients of any power of the binomial provided you construct this triangle here. Now, you obviously should have been wondering, when I was busy expanding these, I don't know them by heart, but what I was actually using, I had this triangle running in the background, and I knew that once I am here, I can get here by adding this and that to get my 4. I add this and that to get my 6. I add this and that to get my 4, and I put a 1 here. Down here, it was 1 plus 5. So you can just write them down. You don't have to do. Of course, you know, there's another way of expanding the brackets manually and so forth. And in fact, I suggest that you need to try one of these expansions. Perhaps, you know, your 1 plus x to the power 4. Expand it manually and make sure that it corresponds to what we have here for the expansion 1 plus x is equal to 4. But that's by Pascal's triangle for you there, and it links directly to the binomial theorem. Till we see you in the next video, bye-bye and thank you.